talk about proportional relationships. When we talk about proportional relationships, we can view it in many different ways. One way is by a graph. If you look at the graph here, what exactly is this graph telling us? Well, it's telling us the number of calendars sold versus how much they cost. So it's really telling us is calendars sold and cost for each calendar. So now, if we look at the next question, it says, pick 2 points. Well, let's pick points. And you always want to pick a point that's in a corner. They're easier to see. One point we can see here is 515. I would say that is my point, 515. 5 on the X line, that's going across, 15 going up and down. So the ratio for this would be 5 to 15. Another point we could find is, again, looking for something in the corner. Here's one up here, 10 and 30. So 10, 30 would be the coordinate point, or the ratio would be 10 to 30. How do these ratios compare? Well, are they proportional? Remember, we learned how to find things that are proportional by reducing them or cross-multiplying. If I reduce 5 over 15, it's going to equal 1 over 3. And if I reduce 10 over 30, it's also going to equal 1 over 3. They are equal. They are equal ratios. Now, we've already answered some of the questions, but what do the table and the graph tell us about the calendars? Well, what this is actually telling us is that each calendar costs $3. So one calendar, abbreviated there, costs $3. And how did the relationship to the ratios you found? Well, they are a constant rate of change is what it's called. As the number of calendars increase, the cost increase. So they are constant. That is something that you'll hear a lot about. Is it constant change? Okay, so as one goes up, the other goes up the same amount. How do you calculate how much the amount of dollars raised of 215 calendars were sold? Well, we just said for $3, I can buy 1 calendar. So I would set up my proportion. How much would it cost me for 215 calendars then? Again, cross multiply and divide. And you're going to find out that 215 calendars actually cost $645. Remember, cross multiply, divide by the lonely guy. Now, let's think about this. You may have found that the top ratio of dollars raised to calendars sold is the same for any value you choose. For example, 15 to 5, 30 to 10. That means for 5 calendars, it costs $15. For 10 calendars, it costs $30. This is what is considered a proportional relationship. We've been talking a lot about proportions and ratios. They are equal ratios. One way of finding those that we've been working on is cross multiply. If you want to know if 2 ratios are equal, you need to cross multiply the first fraction's numerator with the second fraction's denominator, and then do it in reverse. The second fraction's numerator with the first fraction's denominator, and see if they equal the same number. If they do, they are proportional. Now we can also look at figures. Well, if you want to know if a figure is proportional as these 2 triangles, first of all, they have to be in the same position. If you look at these triangles, they are not facing in the same direction. So at first we need to do that. So let's go ahead and turn one of the triangles here. So I'm going to turn this triangle here and put it right on top. And now that the triangles are in the same location, it's easier for me to determine if they're proportional. Let's pick 2 sides. I'm going to put the back base, which is 15 for the small one, over 30 for the large one. Does that equal? Well, we need to pick 2 numbers. It doesn't matter which other 2 we pick. We can pick the bottom here and say, is 23 over 46? we need to know if these are going to be proportional. How do we find out things are proportional? We're going to cross multiply 15 times 46. So cross multiply 15 times 46, and you're going to find out that equals 690. Now do it in the opposite direction. Cross multiply 30 by 23 and see what that equals. That also equals 690. Therefore, they are both proportional. These two triangles are proportional. They are equal to one another. What if I get some rectangles? We want to know if they're proportionals. First, let's set up a ratio. Remember, order matters for ratio. So I'm going to do the width to the length, or the top to the side. So I'm going to say the first ratio is 10 to 35. For B, I'm going to say it's 20 to 45. And you see I'm keeping the same order, making sure if I'm using the top or the width, I'm doing it as the numerator. I'm doing it for every ratio I make. Now I need to see if these are proportional. Well, pick 2, because we want to know if they all 3 are. So let's do 10 is to 35 as 20 is to 45. Are these proportional? Again, we are going to cross multiply and say, okay, 10 times 45, that gives me 450. What does 20 times 35 give me? Well, if I do 20 times 35, I get 700. These do not equal, so that's telling me that these rectangles are not proportional. So your answer would be no, they are not proportional. What about if I use cards? Well, we can find out if things are proportional. We can do the cross multiplying, but in this case, it wants me to find another card. So I'm going to look for a pattern. If I look and I make these as fractions and think of them in that way, the numerator is increasing by 0.5, while the denominator is increasing by 1. So if I increase by 0.5, I could say it's 3. And if I increase the bottom, the denominator, by 1, it's 6. So another 1 could be 3 to 6. That would be proportional. You can also reduce them and find that all of them reduce to 1/2. Now let's look at some pictures. Here's a pattern. Describe how the pattern of the blue and the purple tiles change from one stage to the next. Well, in the first stage, we have 8 purple and 1 blue. In stage 2, we have 10 purple and 2 blue. Stage 3, 12 purple and 3 blue. And the last one, I have 14 purple and 4 blue. So the pattern here describing would be purple increased by 2 while blue was increasing by 1. From the stages shown though, is the number of blue tiles proportional to the number of purple tiles? If we wanted to check, pick 2 of them and cross multiply. Well, 1 times 10 gives me 10. And 8 times 2 gives me 16. So your answer would be no. They are not proportional. They do not equal. Well, now if we wanted to start at stage 1 and draw 2 stages of tiles that is proportional so that they would be working, we would just need to basically copy them. So if I do the first one, I've copied them. Now I have 16 blue tiles, 16 purple tiles, and 2 blue tiles. The next stage I would need to do is copy it again. So in this case, now I have 24 purple tiles and 3 blue tiles. If I use those and cross multiplied, 16 is to 2 as 24 is to 3, I would be able to tell if these are proportional. If I took 16 times 3, cross multiplying, I would get 48. If I cross multiply the other direction, 2 times 24, I get 48. That's how I can tell that they are proportional. Now let's look at some paint cans. Jeff's was making some mixtures, A, B, and C. He says if he adds one blue can and one yellow can each time, they are proportional. Well, is he right? Let's check. The first mixture has 2 blue cans to 1 yellow. The second mixture has 3 blue to 2 yellow. They will have to equal if they are proportional. Well, if I take 2 times 2, I get 4. If I cross multiply this way, 1 times 3, I get 3. They do not equal, so no, his method is not proportional. You can't just add 1 blue and 1 yellow each time. Here is some practice ones. Look at the first one. C is to 52 as 46 is to 26. What do I need to fill in? Remember, cross multiply and divide by the lonely guy. So if I cross multiply 52 times 46, I'm going to get 2,392. And then I have to divide by this lonely guy right here, 26. And I'm going to find out that C equals 92. Because if I took 92 times 26, it's also going to equal 2,392. Go ahead and give these a practice right now, and then we'll talk about it tomorrow.